Have you ever wondered what the real secret sauce is behind all this powerful machine learning? Well, it's not always about having bigger, crazier algorithms or more lines of code. So today, we're going to pull back the curtain and look at the hidden engine that makes it all run: statistics.
You know, we hear it all the time, that to build better AI, we just need more complex algorithms. But what if I told you that's one of the biggest misconceptions out there? See, the size of your algorithm, it doesn't matter nearly as much as the quality of the data you're feeding it.
And that brings us to the fundamental #1 rule of machine learning: garbage in, garbage out. It's a really simple idea, but it has massive consequences. You can have the most brilliant, most sophisticated model in the world, but if you train it on bad data, it's only going to give you bad results. And what's scary is, it'll do it with 100% confidence.
So this garbage in, garbage out problem, it's probably the single biggest reason why so many AI projects fail. And the crazy part? The algorithm itself is almost never the main culprit. So what is?
Get this. A jaw-dropping 80% of model errors come from not understanding the data's distribution. That's right, 80%. It's not a flaw in the algorithm. I mean, just let that sink in. Most of the time, the problem isn't the machine at all. It's the stuff we're putting inside it.
So, okay, how do we possibly fix this? Well, this is where statistics makes its grand entrance. And no, it's not just some boring math class you had to take. In this world, statistics is your quality control. It's how we make absolutely sure our data is ready to go before it ever meets an algorithm.
Think of it this way. You wouldn't try to build a high-performance car without first inspecting every single part, right? You'd want to make sure they're all well-made and are going to work together. Well, your data is no different. Statistics is that crucial inspection step.
So here's the bottom line. Statistics gives you the power and the tools to look at your data, understand all its weird quirks, and check your assumptions before you even think about writing a single line of modeling code. It's your first line of defense against that garbage in problem.
All right, so let's imagine statistics as the dashboard in your car. It's got all the different gauges you need to see what's really happening under the hood with your data. This is what stops us from just driving completely blind. So let's take a look at a couple of these gauges, shall we?
Okay, our first gauge helps us find the center of our data. Now, we all know the mean, right? The average, but it can be so misleading. Imagine you're calculating the average income in a room with 9 regular people and 1 billionaire. The mean salary would suddenly make everyone look like a multimillionaire. The median, on the other hand, is smarter. It just finds the person in the exact middle. It totally ignores the billionaire outlier and gives you a much more realistic picture. Next up on our dashboard is dispersion, which is basically our risk meter. All it does is tell you how spread out your data is. If the variance is super high, it means your data points are all over the place, and that means a whole lot more uncertainty and risk for your model.
And finally, let's talk about the shape of your data, because it turns out a lot of really powerful algorithms like linear regression are kind of picky. They work best with what's called a normal distribution, that classic bell curve you're looking at. If your data has a different shape, like a binomial for simple yes or no questions, you just need to know that so you can pick the right algorithm for the job.
Okay, so we've got a handle on our data's shape and its center, but now we get to the million-dollar question. How in the world do we know if a pattern we're seeing is a real, actual signal or if it's just random noise?
For this, we have this amazing tool called the p-value. Honestly, just think of it as your BS detector. It starts out super skeptical with something called the null hypothesis, which basically says, prove it. I'm assuming there's nothing interesting going on here, that there's no relationship. The p-value's job is to tell you how likely it is you'd see your results if that skeptical assumption were actually true.
So how low does that probability need to get for us to tell that skeptic to take a hike and say, nope, something is happening here? Well, in the world of data science, there's a kind of magic number, and that number is 0.05. This is the threshold we use to make a really important call.
If your p-value comes in at less than 0.05, you get to declare your result statistically significant. What that means is there's less than a 5% chance that what you found was just a random fluke. You can be pretty darn confident the pattern is real and that this data feature is actually worth keeping. It's your filter for separating the signal from all the noise.
So let's bring all this home. By using statistics, we're making a huge shift in our focus. We stop trying to just build bigger, more complicated AI, and we start building smarter and, frankly, more reliable AI.
What this gives us is a clear, 3-step path to a much smarter model. First, you inspect your data. You use statistics to really understand its shape,
its center, and how spread out it is. Step 2, you validate your features, using tools like p-values to kick out the noise. And only then, once you have clean, validated data, do you move to step 3, building your model.
And that is the absolute key takeaway here. Look, the most powerful algorithm in the universe is completely useless if it's built on a shaky foundation of bad data. Statistics is what gives you that solid ground to stand on, making sure your AI isn't just powerful, but that it's also trustworthy, that it's reliable.
So the next time you see some result that an AI model spits out, you'll know that the most important question isn't how complex is the algorithm. It's how good was the data that went in. The algorithm will always give you an answer. But now you're empowered to ask the real question, should I actually trust it?